I'm Bridget Mclaughlin, and I direct the UC Davis Flow Cytometry Shared Resource Laboratories. I run the Flow Cytometry Laboratory. We have two facilities. There's one based in Sacramento and the other in Davis. The laboratory consists of several flow cytometers. We have cell sorters. We have analytic cytometers. We have one Cytek Aurora located in our Davis facility. Essentially, our Sacramento facility is our clinical facility, and in Davis, we have the academic campus where we handle samples from a more diverse range of sample types. Examples of projects that we work with at UC Davis would include HIV immunology. We have a primate center at UC Davis, so we use the non-human primate model to look at aspects of HIV replication and interaction with the human immune system. So that is a large part of the type of samples that we might work with. But we work with investigators who are working with other types of infectious disease models and looking at the immune responses using flow cytometry to assess what's happening with those particular diseases. But we also work with other sample types as well. We have projects looking at exosomes in the field of cancer biology, specifically ovarian cancer, and what types of exosomes are created or maybe at work and at play in transmitting signals from the tumor to the immune system that may suppress the immune system or something like that. We're also looking at exosomes in the milieu of multiple sclerosis as well. So with MS, different patients in the cerebrospinal fluid. We work with veterinary investigators as well with their immune questions as far as veterinary disease agents as well. The decision to purchase the Aurora for UC Davis was chiefly based on the expansion of multicolor detection of different markers, of expanding the number of markers that we could see per cell using traditional fluorescence staining methodology. There are other single cell assessment modalities that are commercially available, but that require the use of specialized reagent sets. And when you're faced with the limitation of the current bandpass PMT-based cytometers in terms of their color limitation, the Aurora seemed to really greatly expand using the spectral deconvolution capability of the Aurora. You could continue to use fluorochrome conjugated protein detection tools in our assays, but do so at a much greater expanded number than what was possible with a traditional flow cytometer. So chiefly, I think it's the expansion in the number of colors, the ability to use standard reagents that every investigator has in their toolkit and already is using for microscopy or something like that. And then, of course, the instrument comes with excellent support and a really good price point. And in a facility where we are at a public institution and funds are not always readily available, we do not have shareholders who are providing us with money, the price of an instrument and the cost of its ongoing support is very important. And so to get this increased bang for the buck was really important to us. Our current system has 3 lasers. It was the original system that we purchased under the early adopter program about 2 years ago. We've been able to achieve 25 color panels and run those types of assays successfully, even on a 3-laser system. But we recognize that with the addition of additional lasers, we then expand our horizons to be able to add additional fluorophores to our staining panels. So 25 is wonderful, but we are precluded from using certain dyes because we simply don't have the UV laser, or we would prefer to have also the yellow-green laser to increase the number of dyes that we can use. So now that those 2 lasers are available for the Aurora system, we definitely plan to upgrade our machine as soon as we can to include those 2 lasers to make our system a 5-laser machine. I believe that expanding the Aurora to include additional lasers, such as the UV laser or the yellow laser, then gives users 2 advantages. Basically, they can choose to expand a reagent panel to 30 or more colors, so that's very attractive to investigators who are studying the effects of cancer immunotherapy treatment and how T cells are responding in other immune subsets. But also having those 5 lasers helps the user who perhaps isn't quite so sophisticated, in that it gives them simply more choice. It allows them to spread. Perhaps they're working on a panel with only 15 or 18 colors, but they now have several different dye choices. Maybe the dye choices are now expanded to 30 or more colors because we have 60-something detection channels. So they have more choice. Even for panels that are limited in number, it gives the user more choice. I can say yes more often to a user who says, can I use this dye on the Aurora if I have those the 5 laser system?